Well, hello, I'm Robert Flagg. I'm a director of engineering at Modus Create. I've been a software developer for over 40 years, and I've been doing Ionic development since version 1. My company, Modus Create, is a digital transformation professional services company. We've been in business for 10 years and have over 500 people in over 50 different countries. And as Matt mentioned, we're also an Ionic partner. Before I start, I wanted to give a shout out to one of my teammates, Grigor Grisagono, for his leadership in the topic. He's a thought leader here at Modus, and I encourage everyone to check out his videos on the Modus YouTube channel. He's super informative, super passionate developer, and really on the cutting edge of a lot of technologies. And I think the link might be somewhere in the Zoom call. Given the audience for this event is enterprise technical decision makers, application architects, application engineers, I focus my talk on helping them to decide if micro front ends are right for them. Micro front ends are a deep and wide technical topic with vastly different approaches and philosophies and vendors out there. And it's a new technology, and as a consequence, there's a lot of different opinions. I'll talk in general terms about MFE architecture, but I mostly wanted to focus on the why rather than the how. But I'll still give an overview of what I think the best implementation patterns are. Most importantly, I wanted to give you some real world examples of how we've helped four Fortune 1000 companies in the financial services, pharmaceutical, telephony, and automotive industries to fundamentally change the way applications are delivered to their customers. We're also doing so by pioneering the use of microservices for backend and micro front ends for customer facing front ends. When these technologies are combined with Ionic technologies like Stencil, Ionic component libraries, capacitor, and portals, our customers are literally saving tens of millions of dollars a year while accelerating their product delivery and maximizing their user experience with highly customized front ends. We all know the benefits of the Ionic platform: write once, run on many platforms, PWA, iOS, Android, and the web. But I think the benefits are not just in reusing code across platforms. It's also about the organizational impact in building teams around a unified language and framework. In working with a major bank to modernize its front end and back end applications, we're seeing the organizational impacts of adopting hybrid technologies. COVID hit this company hard, having to temporarily close 10,000 branches. It highlighted the need for them to be extremely fast and adaptable at delivering digital transformation, both of their organization and of their products. They learned they needed to think like a software development organization rather than a bank. Banks and financial institutions were among the first companies to adopt digital technologies. As such, we see these institutions having some very antiquated application technologies where they can benefit from modernization, specifically moving to the cloud for the benefits of performance, cost, availability, reliability, scalability, and breaking up monolithic applications into microservice. But perhaps the most significant impacts of hybrid standardization were on their organizational team structures. One of the biggest challenges faced by this bank was organizational, not technical. When you have large monolithic applications on multiple platforms, the velocity of new product development is gated by your slowest team. And these disparate teams have to coordinate release activities. It's especially challenging when you have three major platforms, all using different languages, architectural patterns. It made feature delivery really slow. And with every feature team needs its own Ruby engineer, its own Swift engineer, its own Angular engineer, Kotlin engineer, with three different architectures. It was just daunting for them to have any velocity whatsoever. Micro front-end architectures use a singular platform to allow more flexibility in how you organize your team, how members can span multiple feature teams, and how your code is organized. Ultimately, it's proof in the pudding is delivering features faster and getting products out the door. For this major bank, we utilized the micro front end approach to migrate parts of the huge Ruby on Rails application they had into smaller Angular Ionic applications using Node.js-based Angular universal web servers. We literally took a single menu item out of their web application and replaced it with an entirely different platform architecture. We utilized an application load balancer ingress controller to have the routing rules recognize certain routes and then route them to this new Angular application. It's a different pattern than most micro front ends, but it's one in which you have two incompatible platforms living and coexisting very well together. One being a server-side render Rails application, the other being an Angular front end. And then you slowly eat the elephant by picking off pieces, and eventually you end up with you can merge them all into one single page application. Our next step is to move their account servicing mobile applications. We're moving all of their current native applications to Ionic Capacitor, so that ultimately their loan servicing part of their application will be served on the web, iOS, and Android, all from the same component-based Angular application. Any new features added to the existing native mobile applications are actually being developed in Angular Ionic and installed on these existing applications using portals. So this way, their feature delivery is not gated at how fast we can port their entire native application. So it's really an excellent example of how portals is enabling people to migrate to new technologies, yet still deliver features in a timely manner. It's a very timely feature, guys. What exactly is a micro front end? Micro front ends are obviously analogous to microservices, but for the front end rather than the back end. It's really the age-old problem of software engineering. How do we break up large projects into smaller units of work so we can get teams to work independently and in parallel? So we came up with object-oriented programming. Now, if you go and Google micro front ends, honestly, you're going to get confused very quickly. There's a myriad of offerings, opinions, architectures, approaches on this topic. And to be quite honest, some of them are just wildly wrong. You do not want to go down certain patterns. So it's a minefield fraught with a little bit of danger. We'll talk a little bit later about what I consider best practices. In a nutshell, just think of micro front ends as a way of accelerating your application feature development by decoupling your features, your teams, your repositories, and your delivery pipelines sort of into independent units. What we have here is an application that represents an example, just merely an example of a micro front end. It's composed of 4 different micro front ends. We have a shopping view, an authentication view, a cart view, and an analytics component. Note that each of the work streams aligns to a business need and have their own teams. They have their own repositories, and they all have independent delivery pipelines. Down in the right-hand corner, you'll see an application registry. This is kind of a source of truth that's used to know what repositories make up an application. And because when you're building for the hybrid native application, we have to know those build times, those build assets in advance so that we can build them and copy them directly to either the Android or the iOS project. But for the web, we can build them all independently and publish them independently to separate feature URLs. Over here on the right, you'll see like shopapp.com, authApp.com, cartapp.com, analyticsapp.com. So, the build pipeline builds each one of these components, dumps them into an S3 bucket that has a CloudFront distribution in front of it. Then the application, which could be the web application or mobile applications, that shell actually is built with a content identifier, and that application will go out to a CMS provider like Contentful. Most of our clients are actually using Contentful. Use that identifier, read the application config, and bases that application config. It literally tells the main application, okay, your first feature app is shopapp.com. It's located at shopapp.com, and it will go out there, load those assets and those packages to literally assemble the application. There's a little bit of tooling around knowing when all the individual applications are hydrated. And this is kind of the one kind of architecture. It's a popular architecture. This will be used in some of the examples we'll show later, where these modules, even though they're independent, we're using Webpack 5 module federation to ensure that we're not needlessly downloading libraries we don't need to download. The benefits, well, independent teams work with greater focus and for faster delivery. We've always known in software development, small teams with clearly defined objectives work faster, have fewer blockers, and have a clearer mission. Independent repositories make code easier to understand. When we reduce the coupling between the various pieces of our application, it's much easier to go look into the shopping cart application if it's a little standalone application, and now we can see the tree because there's no forest around it. Independent CI/CD pipelines allow independent feature delivery. This is a really big one. It means that each team can develop and publish at its own pace, and that's a highly valued resource, in my opinion. High level of customization is available via the content management systems configuration. It drives, the configuration files drive what features are displayed, how it's being displayed, which data sources to use for content, and how the feature is themed. So you get complete flexibility within your application. We'll see a couple examples of how some of our clients have used that to deliver unique applications. Feature teams aligned to business value. This is especially important when you have applications that have very different business purposes built into them. For example, in our banking client, they have their loan acquisition is not only different from loan servicing, they're also different business units, and it's a lot easier to get those business owners involved if they're only working with the team that's solving their particular problem. Micro-frontends allow heterogeneous frameworks, but it's best to avoid. And I'll go into a little bit more detail on this later. There are instances where this has to happen, but if you're doing any kind of greenfield development, this really should be avoided. There's too many perils around it. And honestly, this really benefits most, is most suitable for very large teams and very large projects. I'll point out some instances later where the approaches aren't really suitable, because in order to reap some of these benefits, you have to have the scale to reap some benefits. Easy A/B testing. I have to say the micro frameworks that we've been working on are the easiest implementations of A/B testing that I've ever seen. So if that is a criteria, some big benefits there. Financial impacts. When you accelerate feature product delivery using Ionic with micro-frontends, you also save a lot of money. We're working with one of the largest pharmaceutical companies in the world, think COVID vaccine provider, to reduce their costs and accelerate their delivery of websites, their regulatory compliance, and their mobile applications. This pharmaceutical is adopted Ionic for all of their mobile applications, and we've helped them develop some reusable website development platforms that are based on Ionic Stencil components and Jamstack. Anytime you have multiple products that have to go through the same processes, in this case, regulatory compliance, website development, mobile application development, for each and every new product, you should seriously consider hybrid-based technologies with micro-frontends. When you speed delivery, you save money. And to give you a scope of that financial impact, These efforts are saving this pharmaceutical company $25 million per year per drug. So that's a pretty substantial impact. Customization, big winner in micro front-end applications. Modus is currently working with a white label application development company that provides the cloud storage solution for many of the top mobile telephony providers. Right now, these applications are being delivered via native applications, but their inability to deliver PWA, web, iOS, and Android features in a timely manner to multiple clients wanting a high level of application customization has resulted them in deciding to move to Ionic PWA and hybrid solutions. This is for an application that has over 100 million users. So that's a real testament to the power of hybrid with micro front ends. Now, obviously, this type of application requires a high level of customization of features and branding, and this is perfect for micro front ends. Not only can their clients easily choose which features to include, how the features are organized, how the features are customized. For example, let's say you want somebody to display as a grid versus a carousel. They can now also control all of the branding and all of the UI UX components entirely from configuration. Target market customization. This is a really interesting one. Because micro-frontends make it easier to dynamically customize content at runtime, there are new opportunities for geographic customization for your application. Modus is working with one of the leading European auto manufacturers to use micro front ends to provide highly customized user experiences tailored to specific markets. And for this manufacturer, that's 160 different markets. Long before COVID, digital transformation was fundamentally changing the way people buy cars. People were increasingly turning to manufacturers' websites to browse and configure their purchase, so that, a lot of times dealers were order takers. COVID shutdowns obviously exacerbated this trend. Indeed, some manufacturers like Tesla have eschewed car dealerships entirely and sell direct. While websites have long provided localization and language translation for different markets, it's been a challenge to easily tailor content and user experience for culturally diverse markets and regions. Spain's preferences tend to be different than Eastern European markets, and heated car seats are not much in demand in Southeast Asia. But micro front ends allow for exactly that level of customization, not only in what is displayed, but how the content is displayed. For example, in Germany, Germans want to control every single feature specification. In the US, people tend to prefer the simplicity of trim levels. And that trim levels obviously have there's a reason they do that. The manufacturers do that because they can ship inventory around the world and be reasonably confident that there's, something that someone, customer will find that fits their need without having to build everything custom. Now you can imagine trying to build such a level of abstractions into a monolithic website would be daunting, and you'd be right. I've done it several times in my career where you try to build a dynamic user experience driven off of metadata, and it's incredibly difficult. Micro front ends solve a lot of those kinds of issues, and just remember that it's a pattern as much as a technology or a framework. And when you recognize that, there's tremendous new opportunities to reusing these patterns to solve problems in different ways. So it's really exciting and a challenging field. Patterns, what kind of represent the best patterns or approaches in building micro front ends? I would say number one is pick a framework. Now, in theory, you can build applications with completely different frameworks for each micro front end. In some cases, it's just necessary. So we've got the financial institution where we're doing a migration from one, Ruby on Rails to Ionic Angular. you're stuck with two different platforms. You have to live with that. Another particular use case is two firms merge. One's got all their products and their assets in React, and the other is in Vue. But you need to merge those assets and get them together as to one entity. Micro-frontends can solve those problems, but the reality is, if you're doing greenfield, that has serious drawbacks with respect to performance. A better pattern is to utilize a common framework. And when doing so, I recommend favoring browser-based standards like custom elements. While theory stresses trying not to share code, the reality is that the performance challenges dictate that using a single framework and a module sharing technologies have big impacts in improving your performance. So we make some sacrifices to have some contractual standards across the teams, but we reap major benefits in performance by being able to share dependent modules. My favorite approach is Webpack 5 module federation. It's based on standards. It's not opinionated. It's very robust, and it's very well known. So it's a pretty good approach, and it's being used by being used by both our auto manufacturer and our white label application. Now, there's also important when you're establishing those dependencies early on. Recognize what they are, what your shared dependencies are. Very common ones are navigation, authentication, user identity, themes. These are instances where having a good pattern around how you architect and having some shared resources can be very, very valuable. In many cases, service workers are very helpful in this regard, especially in around authentication. Some of our clients are using service workers to intercept all the feature applications fetch calls so that authentication headers can get added. So that's shared across all feature apps. Think runtime over build time. The goal is to assemble applications. This obviously rules out things like Git submodules and NPM libraries. No, this doesn't mean you can't, feature apps can't use shared components from an NPM library. Indeed, most of our feature application developers are using Ionic framework components. You're just doing so at the lowest level. And again, those libraries with module federation do get shared. They're compiled independently at runtime. This approach also, decouples your release pipeline entirely. And if you build in semantic versioning of your releases from the outset, you'll find that your applications can be very robust when you're releasing multiple versions at a time, and teams are releasing versions independently, and older versions of wrapper applications can still work. Other good thing to follow: establish clear naming conventions to prevent name collisions or CSS leakage. Again, stencil compiled custom elements go a long way in aiding this. It's kind of the pattern of browser-based standards that is going to work and reap great rewards. Browser features over custom APIs. Utilize browser-based event communication over global state management with PubSub to eliminate all your cross-cutting dependencies. I'm a big fan of reactive functional programming with PubSub interfaces, but those tend to be too tightly coupled for MFEs, and it's going to be too easy to break your modules, and it introduces dependencies between your feature apps, which you're really going to try to avoid. Hydrating multiple feature applications on the client side can have some performance impacts. There's a lot of stuff to download. So consider using server-side isomorphic rendering technologies to improve your perceived performance and your time to first contentful paint. That's always a good strategy. And again, the goal in micro front ends is to have the most minimal coupling, but you will have shared dependencies like auth tokens, user identity navigation. Identify these early, and obviously it will benefit performance, if everyone's sharing the same version of React DOM, because if you don't, it will download multiple versions of React DOM. So there's an obvious role for infrastructure around your teams, to enumerate what those shared core dependencies are. A lot of teams are using evangelists that sort of are conduits between teams to establish these rules that make sure that everyone's playing nicely. You can have version conflicts. It won't break anything. It just may impact your performance, and it's just not optimal. Also consider using monorepos and package management tools like NX for Angular or Lerna for React to sync your version dependencies and optimize module federation. So developing some core tooling that teams can reuse is super helpful in that regard. And then there's reality. Finally, don't get religion on micro front ends. They're not appropriate for everything. While I've painted a picture of sunshine and lollipops, the reality is that building micro front ends are hard. Some would say they're very hard. Micro front ends have the same restrictions as microservices. So you have to honestly evaluate if the juice is worth the squeeze. For most simple applications, this is not the case. Even with some complex applications, it may not be worth the investment. For example, I never recommend startups build microservices or micro front ends. In order to be successful at building microservices or micro front ends, you have to have a very clear understanding of your domain boundaries, and startups, which are acting agile, don't have that. They can't know what the thing is that they're ultimately delivering. Two, the goal of a startup is to get to market quick, get customers quick, prove their value proposition so that they can A, raise more money, or B, make money to be able to afford fix their technical debt. The perfect architected system that never ships is just a waste of time and money. And so on that cautionary tale, I think we have maybe a little bit of time left for Q&A.